Okay, so today we're going to talk about the nature and phase change. Some of you guys have already gotten some of these notes. I'm just going to go through the whole packet, and you can fill in as you need to, wherever you need to. So the first thing we need to talk about is the kinetic theory. Now, we talked about the kinetic theory in the guided reading, and remember, it's just an explanation of how particles in matter behave, okay? Specifically, assumptions 1 or 2, or parts 1 or 2, are true of solids, liquids, and gases, whereas parts 3 and 4 are kind of more specific to gases. Okay, so really what we're interested in is, the first and the second assumption. So the first assumption, as you may recall from the guided reading, was that all matter is composed of tiny particles. These particles, as you get more specific, can be called atoms, molecules, and ions. And in the next unit, we will look at those in depth. Number 2 assumption, part 2, assumption of the kinetic theory says that these particles are in constant random motion. Now, you probably know what constant is, but you might not know what random means. So what we mean by random is that these particles move in different directions at all different speeds. Okay? You can't really predict where the particles are going to move. Okay? And this is true of solids, liquids, and gases. Now, to understand this, you have to have an idea of what kinetic and potential energy are. Because when we say that these particles are constantly moving, what we mean is that they have a kinetic energy. Okay? So you might remember from middle school that Ke, or kinetic energy, is the energy of motion. Okay? Any particle, anything in motion is said to have kinetic energy. Now, potential energy is a little bit more difficult concept to understand. Potential energy is what you might call stored energy, and it's a little bit more difficult to understand for students. It's a little bit more difficult concept. The stored energy that particles are going to have has to do with the particle's position. Okay, so if you want to put underneath here in parentheses position, and we're going to talk more about that, especially when we look at the graphing that you guys did on Thursday of last week. So part 3 and 4 of the kinetic theory, more specific to gases, are that these particles these gas particles collide with each other and with the walls of the container in which they are held. This we showed, or we kind of demonstrated when we were, running around the room like maniacs. Okay? Now, this amount of energy, when the particles run into the container or the walls of the container or into other particles, they lose a little bit of energy. But this energy is what we call negligible. And that word negligible, which I'm going to spell, I think I spelled it right there, means very little. They lose very little energy, so much so that we don't even count it when they run into each other and when they run into the walls of their container.